Two-Dimensional Time by Lewis Powell. We measure time every day, but a lot of times we don't know exactly what time is. Many say that time is the force keeping everything from happening all at once, or the recording of our present event that we're in into our memory. Whatever time is, we measure it every day by seconds and minutes, hours, days, and years. A space location given to someone doesn't mean a lot unless a time location is also given. A space location could be meet me at the restaurant, but unless you specify a time, your friend isn't going to know when to meet you. Time is a very important asset that we do not control and very few understand. Time can be described briefly or casually as moving from one event to the next event. Like a baby becomes a child, that child becomes a teenager becomes an adult, and then the adult becomes a senior. We refer to this as the passage of time, passing through time. Whatever time is, the events that are involved in measuring or recognizing time occurs both in the space dimensions that we live in and the time dimension. If we could take the Earth and push it inside a giant ice cube at absolute zero and freeze all of the events, would time stop? Julian Barber suggests that we're not just moving through time, but we're actually moving from one position in the universe to the next position in the universe. He suggests that we're just a shadow of a six-dimensional world. He says, it is suggested that the world we see around us is merely a shadow of a six-dimensional world. According to this idea, the standard model, which would be our world, is just one shadow of this six-dimensional world. An extra time dimension is very real. This is from the Discover magazine, March 2012, under a title of, Is Einstein's Greatest Work All Wrong Because He Didn't Go Far Enough? We recognize four dimensions in our environment. Length, width, and height we recognize easily. We can measure them, we can touch them, we can examine them. But that one dimension of time makes us confused a lot of times, and defining it really is more difficult than what most understand. I'll give you an example. If we tell two friends we want them to meet somewhere on the equator, that would be meaningless because we wouldn't tell them exactly where and we wouldn't tell them exactly what time to meet. What we would need to do if we wanted our friends to meet would be to specify the three space dimensions and the one time dimension. Length, width, and height would become on the equator at the prime meridian at sea level. And the time would be January 1st, 2014, 10 a.m. Eastern Standard Time. With this information, our friends could find each other easily. What happens if we remove one of those space dimensions, which would move us to a three-dimensional world instead of a two? Our world would become flat because we would eliminate the height. Our friends couldn't meet in the air and they couldn't meet below the ocean. And so the world would be flat. There would be no altitude. And by removing the height, our world would be flat, like a map, with only length and width, no height. We could go a step further and we could eliminate the width. And if we did that, we would have one space dimension and one time dimension. In trying to imagine this, we can compare our one space dimension to our one time dimension. Our world would no longer be flat, it would become a line. No width and no height, only length. Our world would only be a line, like the equator. And we can compare that to a one-dimensional time. Is time one-dimensional? To us, time is a single dimension in everything that we observe. We have an event happening at a particular time, and time is continually passing. Time is like a measuring tape, increasing with every millisecond. But some are suggesting that time is not a line, but two-dimensional, like the map, length and width. Time may appear more like a shadow having length and width than a line. A theory of everything is being sought by many, many scientists. In order to solve certain quantum irregularities. Some scientists are working to prove that time is not one dimension, but two dimensions. Examining this possibility reveals an astonishing conclusion. The theory of everything is sometimes called M theory. And today, scientists are studying the theory of everything, the M theory, suggesting that there are 11 dimensions, 10 of space, 1 of time. Others working on the same theory are suggesting that no, not 11, 13 dimensions, 11 of space and 2 of time. Proposed 13 dimensions would consist of the length, width, and height that we can observe, plus 8 other dimensions that would be so tiny they wouldn't be recognizable by humans. But there would be 2 dimensions of time, not just one. Years ago, Albert Einstein came along just about the time when everyone thought they understood what time was, and he introduced an amazing idea that time is relative. It's relative to velocity. The faster you travel, the slower time passes. That's been proven. It's also relative to gravitational pull. The stronger the gravitational pull, the slower time passes. This has also been proven. Now we almost get a grip on time being relative to velocity and gravity when another scientist, Dr. Bars, comes along and tells us that time is two-dimensional, not just one. And he says if time, is confirmed to be two-dimensional, it could point the way to the theory of everything that unites all the physical laws of the universe into one, notably general relativity that governs gravity and large-scale structures of the universe, and quantum theory that rules the subatomic world. He is over the Department of Physics and Astronomy at the University of Southern California. This is an image of two-dimensional time. The sheet that is upright, standing vertical, would be time. It would be two-dimensional. It would have length and width. And space, which is represented here by the horizontal sheet, would intersect time. Where that intersection occurs, it would be a single dimension of time. This is observable by us. We can recognize going from an earlier time, say at 1:45, to a later time at 10:45. But with a second dimension of time, clocks can run backwards as well as forward. Is two-dimensional time possible? David Goldberg suggests that it's not. And he says that every person and particle, for that matter, would move through 2 different times, T1 and T2. But these 2 times can't proceed at exactly the same rate, because if they did, it would be exactly the same as if the universe had only 1 dimension of time. He continues to remind us that there is an inverse square law on gravity. The idea is that if you double the distance between 2 objects, their force of gravity drops by a factor of 4. The same rules holds for electromagnetism. The inverse square law isn't an accident. It turns out that it's entirely a function of the fact that we live in a 3-dimensional universe, 3-dimensional space universe. If we lived in a 4-dimensional space universe, then we would have an inverse cube law, and this would create all sorts of problems. Because the gravitational pull at a distance, say the radius of the Earth, an object would have a certain weight, and at 2 distance it would be squared, so it would have 1/4 of the force of gravity. And at 3 being squared would be 1/9. If we add that additional dimension in space, though, Dr. Goldberg tells us that the inverse cube law would take effect, which would mean that at 2 distances, we wouldn't have 1/4 of the gravitational force, but 1/16. And at 3 distances, not 1/9 of the gravitational force, but 1/243. And at the 4th distance, which would normally in the inverse square law would be 1/16 of the force of gravity, it would be 1/1024, which makes a huge difference in our world. In fact, Dr. Goldberg tells us that higher dimensional universes don't have any stable orbits because of this inverse cube law. In a 4-dimensional space universe, the Earth would either spiral in toward the sun or fly away. This is true for all orbiting bodies, including planets, comets, stars in the galaxy, and so on. It also affects the subatomic world. Any of the electrons orbiting around the nucleus would be affected by the same gravitational reduction. So is there a solution to this dilemma? Well, research shows the problem disappears if the theory involves one more spatial dimension. So many people are adding 4 space, 2 time dimensions, generalized in a 6-dimensional space-time. We simply add 1 spatial dimension for a total of 4 to the 2 time dimensions. And so we have a world of 6 dimensions. Many of the physicists are saying we don't live in that 6-dimensional world. Instead, what we are is a shadow. Our world is a shadow of the 6-dimensional world. It is suggested that our world we see around us is merely a shadow of a 6-dimensional world. According to this idea, the standard model, our world, is just one shadow of this 6-dimensional world. An extra time dimensional is very real. If we look at Colossians chapter 2, verses 16 and 17, it reads, "Let no man therefore judge you in meat or in drink or in respect of a holy day or of the new moon or of the Sabbaths, which are a shadow of things to come, but the body is of Christ." Is our world a mere shadow of a 6-dimensional world? When we create the idea that there's 2 dimensions of time, we have to consider whether we're a shadow of a 6-dimensional world. 2 Peter 3:8 says, "But, beloved, be not ignorant of this one thing, that one day is with the Lord as 1,000 years, and 1,000 years as one day." One day is where we live. We have one day is always equal to one day in the environment that we live in. One-dimensional time would always give us one day equals one day. This is what we can observe. We can live and we can imagine one dimension of time. But if one day could be equal to 1,000 years, then that is 2-dimensional time. For one day to have a characteristic that is not equal to one day, then it has to have length and width, not just a line, not just a single dimension. It has to be a dual dimension. A 2-dimensional time is something that we cannot observe, but it could exist. But we would never be aware and never be able to observe it. This creates a serious dilemma. If we look at Luke chapter 16, verses 24 and 25, it tells the story of Father Abraham, where the rich man and Lazarus had both died, and Lazarus went to be with Abraham, and the rich man was in hell. And the rich man is calling out to Father Abraham. He says, "Father Abraham, have mercy on me and send Lazarus so that he may dip the tip of his finger in water and cool my tongue, for I am tormented in this flame." But Abraham said, "Son, remember that thou in thy lifetime receivest the good things, and likewise Lazarus evil things. But now he is comforted, and thou art tormented. And besides this, between us and you, there is a great gulf fixed, so that they which would pass from hence to you cannot, neither can they pass to us that would come from thence." It's an interesting Greek word used for gulf. We transcribe it as chasms. According to the Word Studies of the New Testament by M.L. Vincent in 1887, that word is descriptive of a great divide. Now, if we look at the word great gulf fixed, if we look at the word great, the Greek can also refer to time. So it would be a great division or a time division, a great time chasm or division of time. So the verse could be, "And besides all this, between us and you, there is a division of time fixed." If we look at Jude chapter 1, verse 6, "The angels which kept not their first estate, but left their own habitation, he hath reserved in everlasting chains under darkness unto the judgment of the great day." This word first estate refers to magistrates, power, principalities, principal, rule, but in various applications it can refer to order and it can refer to time or place. So placing the idea of time there instead of space, then it would read, "And the angels which kept not their first time dimension," which would match with the idea that there is 2 dimensions of time. Our world consists of what we can observe, 1 dimension of time, but it could also have a second dimension where time and space intersect. 1 dimension is created, but time can be 2-dimensional. We can only see and observe 1 dimension of time. But with a second dimension of time, clocks could run backwards. Time could go backwards. And the reason for that is because we could move off of that line and into the field of length and width and relocate ourselves at a previous period on the single dimension of time. Is 2-dimensional time a reality? Well, until there is a confirmed theory of everything, which unifies the general relativity of our world and the subatomic quantum world, there is no way to prove whether time is 1-dimensional, 2-dimensional, or if time exists at all. But one thing stands clear. The Bible presents a division within our world that is powerful and real. We just haven't discovered how to define it yet.